Okay, today's aim is how do we approach triangle similarity proofs. So before we discuss how we approach triangle similarity proof, let's first review the three ways you can prove two triangles are similar. So the first one is called the angle-angle similarity postulate, which basically says if two angles of one triangle are congruent to two angles of another triangle, the two triangles are similar. So in other words, if angle A is congruent to angle D, if angle A is congruent to angle D, and if angle B is congruent to angle E, this is an example, if angle B and angle E are congruent, then that makes these two triangles ABC similar. ABC and DEF are similar. So that's one way, the angle-angle similarity postulate. From that postulate, we know of two theorems. The first one being the side-angle-side similarity theorem, which says if two angles are congruent, so in other words, if angle A is congruent to angle Q, and two corresponding sides are proportional on either side of those angles, then the two triangles are similar. In other words, if AB to QR, if AB is to QR, as AC is to QS, as AC is to QS, and these included angles are congruent, the green angles that I've highlighted, if they're congruent, then these two triangles are similar. Then ABC is similar to triangle QRS. Another triangle similarity theorem is the side-side-side similarity theorem, which basically says if three sides of one triangle are proportional to three corresponding sides of another triangle, in other words, AB is to QR, AB, let's do this in red, AB is to QR, as AC is to QS, as AC is to QS, as BC is to RS, as BC is to RS, then these two triangles are similar, and that's called the SSS triangle similarity theorem. So these are the three ways I can prove two triangles are similar. Let's take an example. So let's take the first one, and let's first reorient our board. Okay, so let's take a look at this question. Given FG is equal to GH, and FG is equal to GH, and JK is equal to KL, and angle F is congruent to angle J, prove that triangle FGH is similar to triangle JKL. So the first question is, which of the three triangle similarity postulates or theorems am I going to use? Can I use AA? Can I use SAS? Can I use SSS? Well, for me to be able to use SSS, I would need to know the lengths of the three corresponding sides. And I don't. I know two sides are going to be proportional. FG is going to be to JK as GH is to KL, because I know these are two isosceles triangles, but I have no idea what the third side is. I don't know what the length of FH or JL are. So SSS, can't use that. Side, angle side, well, I would have to know the lengths of two sides, and I would have to know that the angle in between those two sides are congruent. I don't know that. It's not telling me that angle G and angle K are congruent. No, it's telling me that angle F and angle J are congruent. So that's not going to work. So side angle side is also, side angle side is not going to work. So the only one that looks like might work is angle angle. Okay, so how am I going to use angle angle? Let's take a look. So first order of business is let's walk through this. So FG is equal to GH and JK is equal to KL. That means that I have two isosceles triangles. What do I know about isosceles triangles? Well, I know that in an isosceles triangle, the base angles are congruent to each other. So I know that angle H and angle F are congruent to each other. I also know that triangle JKL is also an isosceles triangle, which means that these two angles, angle J and angle L, are congruent to each other. But what actually ties these two triangles to each other? What connects them? What connects them is this. Angle F is congruent to angle J. Let's see what the plan is. I'm going to try to use the angle-angle triangle similarity postulate to show that triangle FGH is similar to triangle JKL. So I'm going to say that triangle FGH is isosceles, which means that angle F is congruent to angle H. I'm going to say that angle JKL is also isosceles, which means angle J is congruent to angle L. What connects these two triangles are these two angles. If F is equal to H and J is equal to L, and F is equal to J, that means that H and L must be congruent to each other. Well, if angle H and L are congruent to each other, and angle F and J are congruent to each other, then these two triangles are similar because of angle, angle. So, let's get right to it. So, first order of business is FG is congruent to GH, and also JK is congruent to KL. The reason for that is given. So these are my statements. These are my reasons. Statement number 2. If this is the case, I can say that triangle FGH is isosceles. And I can also say that triangle JKL is isosceles. Right? What allows me to say that? Well, that's the definition of an isosceles triangle, right? That's the definition of isosceles triangle. What is an isosceles triangle? The definition of an isosceles triangle is a triangle where two sides are congruent to each other. So I know these are two isosceles triangles. What is statement number 3? Well, what do I know about two isosceles triangles? What do I know about any isosceles triangle? That the base angles are equal. So I can say that angle F is congruent to angle H, and I can also say that angle J is congruent to angle L. Why? Because those are the properties or property of isosceles triangle. Base angles of an isosceles triangle are congruent. Okay, what else do I know? Statement number 4. Statement number 4 is what is given to me, namely, angle F is congruent to angle J. Reason for that? Well, it's given. Okay, so let's see what I've got here. I've got angle F is congruent to angle H, right over here. I know angle J is congruent to angle L. And I know angle F is congruent to angle J. What I really want to say is that angle H and angle L are congruent. How do I do that? Well, let's see. So I'm looking to show that angle H and angle L are congruent. I know F is equal to J, and I know F is equal to H. So that means J is equal to H, right? So in other words, I can say that J is equal to H. Statement number 5 is going to be that angle J is equal to H. If F is equal to J and F is equal to H, so I'm looking at these two pieces right over here, F is equal to H and F is equal to J, that means angle J is congruent to angle H. And I also know that angle J is equal to angle L. Right over here, I know that J is equal to angle L, right? Well, if J is equal to angle L, because of what I have right over here, what I said before, and I know that J is equal to H, then my next statement could be that angle H is equal to angle L. Angle H is congruent to angle L. The reason for this is going to be the transitive property. If you want to use substitution, that is perfectly fine. I like transitive property better. Well, here's the deal. If H is equal to L, and I know that F is equal to J, that is what's given to me, then the sixth and final statement can be triangle FGH is similar to triangle JKL, triangle JKL, because of the angle-angle similarity postulate. And there you have it.